networking concepts. So mainly, first I just want to start with a few basic networking concepts. Okay, I just want to cover them. After that, we'll deep dive into Netapp networking concepts, like what all the things we need to configure which are related to networking. Okay, so first thing is I just want to discuss about IP address. Okay, IP address. So when you are talking about a LAN network or internet, the first thing which will hit our mind is IP address, because without IP address, we'll be not able to identify anything. Okay, or will be not able to connect to any other device without a IP address, right? For example, as we discussed earlier, right now, for example, if you try to access a Facebook, Google, or whatever it is, a banking website, everything, okay, in the back end there is a IP address mapped to that particular name, DNS name. Okay, with the help of that IP address only, it will connect to that server where we have hosted the website, like a Facebook application or whatever it is. From there, it will uh, we'll be able to access that particular site. Okay, so there are two versions of IP addresses. Okay, two versions of IPs. Just a second, guys. Okay, sorry for the delay. Sorry for the break. So yeah, as we discussed earlier, there are two types of two versions of IPs. Okay, IP address. First one is IPv4. Second one is IPv6. Okay, so right now we are most of the organizations are still using IPv4. Okay, they are still using IPv4. Very few companies like very big organizations like Facebook, Google, these guys only started using IPv6. Okay, so what is the difference between IPv4 and IPv6? Normally IPv4 address looks similar to this, like 10 dot 64 dot 10 dot 13, something like this. Okay, it contains only 4 digits. Okay, typically looks like this. But when it comes to IPv6, IPv6 address looks very complex. Mm, okay, it contains lot of addresses. I can't type it now. Let me show you an example for IPv6. Okay, it looks like this, IPv6. Okay, so like what is the difference between IPv4 and IPv6? Generally, there is no difference. Both are same only. Only thing is IPv6 is designed for future purpose because IPv4 has very limited IP addresses. Okay, less limited IP addresses. For example, if nowadays everyone is starting companies and they started using IP addresses, right? And one more thing is the usage of internet also growing. So maybe very soon we might run out of IPv4 address. That time all of us must start using IPv6. Okay, IPv6 is for future actually. Right now, most of the people they are still using IPv4 only. Okay, so don't worry about IPv6 for now. Let's discuss about IPv4. Normally, okay, a typical IPv4 address range, it is between 1 to, okay, 1 to 255. Okay, 1 to 255. That means it starts with 1 and ends with 255. Starts with 1 and ends with 255. So again, whatever it is there in between 1 to 255, they have divided them into classes. Okay, they have divided them into classes like class A, class B, class C, class D, class E, like that. Okay, generally we don't use 255. 255 has a different purpose. Okay, and we don't use zero as well. Okay, zero, we discussed about it, right? When we are creating export policy, zero IP means nothing but everything. Okay, that's the reason we don't use zero as well. So basically, normal IPv4 address range will be like 1 to 254 generally. Okay, so 1 to 126, they have categorized it as class A, class A, 1 to 126. And the subnet mask of class A IP address is 255.0.0.0. Okay, so in class A, the range of class A is 1 to 126. That means 1.0.0.1, 1.0.0.2, like that, up to 1 dot, sorry, up to 126.55.255.255. Okay, this entire range we'll call it as class A. Okay, and in class A, only the first letter is a network address, remaining all digits are host address. That means network digit in a single network will not change. Okay, whatever the remaining host address are there, right? Those things can change within a network. That means in one dot network, okay, one remains same. The remaining things are there, right? Like 1.0.0.1, 1.0.0.2, like that. They can keep on changing till where, like 1.255.255.255. That is the last IP address in one. So here, this everything belongs to same network only because my network address remains the same. Only host address keep on changing. That means this entire all these IPs belongs to same network. Okay, all these IPs belongs to same network like 1001, 1002, 1003, 1004, like till 100.255. After that again it will start one here in second digit 100. sorry, 10, 11, 10, 12, 13, like that. 10, 255, after that it will 2 again, 2 will come in here, like that. We'll be having so many IPs in class A. Okay, so if network digit changes, then network also got changed. For example, 2.0.0.1, this is also class A only, but this is a different network, because the network digit got changed here, which is a our first digit. Okay, host digits can change, but network digit should remain same in a single network. Okay, so here in class A, 1 dot is one network. Okay, like that. 2 dot is another network. 3 dot is another network. 4 dot is another network. Like that, up to 126. That means how many networks we have here in class A? Total we have 126 networks in 126 networks in class A. Okay. So what is the subnet mask of class A? 255, sorry, 255 dot 0 dot 0 dot 0. That is the subnet mask of class A. That means for network digit, it is 255. For all host digits, it is zeros. Okay, because they'll keep on changing, right? That's why they are host digits. The one which remains constant, it is a network digit. Yeah. Any question? Sorry. Okay. Not able to hear anything if someone is talking. Okay. So this is a class A. So class A range is 1 to 126, and in class A, the first digit is a network digit, and all remaining 3 digits are host digits. In a single network, network digit remains same, only host digit will change. If the network digit got changed, that means that is a again a different network. Zubair, if you are talking, I'm not able to hear you properly. Are you talking to me or are you talking there with your family members? I'm not sure, but yeah. Zubair, I'm not able to hear you. Your voice is very low. Please use a headset or earphone. Don't talk on speaker. Okay, yeah. So the first digit, which is a network digit, remains same in a single network, and remaining host digits can change. Yeah, bro, I can't hear you, bro. Not sure if anyone else can hear that and can repeat it for me. Zubir, if you have any question, let's type it here. Type it in the chat because I'm not able to hear you properly. Yeah, please type it. I'll look at it and I'll answer it to you. Okay. So yeah, now what is network actually? So when I have 3 servers, okay. If I want to establish a communication between them, what do I need to do? I need to assign IP address in the same network. Like for example, 100. Let's assume that I have one server. For the first server, I'm using 1.0.0 uh, 1.0.0.10. Okay. For the second server, I'm using, let's assume that 1.0.0.11. Okay. For the second server, I'll be using a different address. Zubair, please, just a second. Guys, are you able to see my screen?
Yes, Anaya.
Yes, yes.
Yeah, Zubair, it's your issue only.
I think
Maybe,
he's facing the network issue. I think so.
yeah, you're facing a network issue, Zubair. Yes, because everyone else, they'll be able to see my screen. Yeah. So yeah, whenever we are assigning IPs, we mostly will assign the IP address within the same range only, like 100.1.0.0.12. Okay, so if you assign IP address within the same network to all the servers, then they'll be able to communicate with each other without any issues. But for example, let's assume that I got one more server, but here instead of a one dot network IP, let's assume that I have used something called 10.0.0.23. Then all these three servers will be not able to communicate with that fourth server because my fourth server is in a different network. I can establish the communication, but I need to do some additional configurations called routing and all. Okay, these things we don't need to worry about these things, guys. Okay, because all these things will be taken care by network team. Just I am explaining to you because if you have knowledge about these things, it will be better for your career. That is the reason I am explaining the network concepts as well. Okay, so did you got it? What is class A? So class A range is 1 to 126, and first digit is network digit, and remaining all three are host. Network digit remains same in a single network. Only host digits will keep on changing. If the network digit got changed, then it is a network also got changed. Okay, like that. So Zubair, are you able to see my screen now? Let me reshare it for you. Okay, let me reshare. Okay. So you better to be on proper network, or else it will be, yeah. Okay, so as I told you, so how many networks we'll be having in class A? It is 1 to 120. Guys, are you able to hear me? Hello.
Yes, Anaya.
Okay, power cut. Okay, yeah, let me share my screen again. Okay, so yeah, this is a class. Next, class B. So in class B, the range is 128 to 191. That is the range of class B. So in class B, the subnet mask will be like this, like 255.255.0.0. That means here we'll be having two network address and two host address. Two network address and two host address. That means 128.0.0.1, 128.0.0.1, to up to what is the end IP address of this particular network? 128.0.255.255. This is the last end IP address of this network, because here first two digits are network digits, second two digits are host digits. That means host, as I told you, host digits can change, but network digits cannot write in a single network. If one of the network digit got changed, then that is a change in network. That means 128.0 is a different network, 128.1 is a different network. Okay, what is the range actually? 128 to 191. Okay, that is the range of class B. So what is the subnet mask of class B? 255.255.0.0. Okay, that is the subnet mask of class B. So how many networks will get in class B? 16,384 networks will get in class B. That means 128.1 is one network, 128.2 is one network, 128.3 up to 128.255. Same thing with 129, 129.1, 129.2, 129.3 up to 129.255. Like this, 128, 129, 120, 130, 131 up to 191. In 191 also 191.1, 191.2, like that. How many networks will get? 16,384 networks will get in class B. Okay. Next, class C. What is the range of class C? Class C range is 192 to 223. That is the class C IP address range. In class C, we'll be having three network addresses, one host address. That means that is the reason the subnet mask of class C is 255.255.255.0. Okay. So that means first digits are network digits. Okay, first three digits are network digits. Network, 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 host. Okay, so if any of these three digits got changed, then that is a change in network. But host digit, as I told you, it can change. So in our lab, we are on 192.168.0. This particular network. Okay, this particular network. That means the range of this network is 192.168.0.1 128 dot sorry 192 192.168.0.255. Okay, this is a class C network. 192.168.1.1. Again, this is a different network because one of the network digit got changed from 0 to 1. That means this is a different network. So the number of networks in class C is very high. Okay, so we can have like 20 lakh 97,157 networks in class C. That means because 192.0.0 1 is a one network, 192.0.1 is a one network, 192.0.2 is one network. Like that, we'll be having so many networks in class C. Okay, did you got it? What you need to understand is what is a network digit and what is a host digit. Those things you need to understand. So in class A, only one network digit, three host digits. That means network digit should remain in a single network. If network digit got changed, that means that is a change in a network. Okay, like that. In class B, two network digits and two host digits. In class C, three network digits and one host digit. Okay. Always in a single network digit should remain the same. If network digit got changed, then that is a change in network. So in order to enable the communication between two different networks, you need to do additional configurations. Okay. Next, class D. Class D range is 224 to 239. Okay, and we do not use class D anywhere. Okay, class D has a separate purpose, that is for multitasking. Class D is used for multitasking. Okay, actually not multitasking. We'll use it for broadcasting, multicasting, these kind of things. Um, I think you heard of broadcasting and all. Broadcasting means nothing but, for example, we are using FM radio, right? Anyone with FM capability can hear that, because what FM they'll do, they'll just release the signal in the air. Okay, they'll just broadcast the signal to the air. Whoever can receive, they can hear that. Okay, that is the example for broadcasting. Okay, what is multicasting? For multicasting, our telephone is a good example for multicasting. Only two people can communicate with each other, or more than two people who are on that particular channel can talk to each other. That is a multicasting. Okay, unicasting is a nothing but walkie talkie. Only one person can communicate at one time, right? The other person has to wait for his turn. That is a unicasting. Okay, like that. For this kind of purpose, communication purpose, the class D network is reserved. We don't use class D network range in any of our environment infrastructure. Okay, so we don't need to worry about class D. Next thing is class E. Class E range starts from 240 to 254. Okay, again, this is a, we don't use class E as well in our environments, because class E has a separate purpose, that is for research and development purpose. Like whoever the do, like for example NASA, these kind of research organizations are there, right? They'll use class E IPs, okay, for security and purpose. Okay, so normally in our environments we will be able to see only class A, class B, and class C IPs only. Okay, any questions, guys? If you don't understand also, this is fine, because this is, we are not responsible for this network team. But I just want to make sure that if you have this knowledge about IPs and all, it will be good for you. That's it. Yeah, someone asking question. Hello, are you able to hear me?
Yes, Anaya, no questions for my end.
Okay, cool. Okay, that is the ranges of IP address. So let's start our Netapp class. So first thing we'll discuss about in Netapp networking concept is, the first thing is IP space. Okay, first thing we'll talk about is IP space. So what is the purpose of IP space? Okay, we'll talk about that. For example, let's assume that I have a cluster. I have a 4-node cluster. Okay, these are the 4 nodes, and I have created a cluster. Now, by using this same cluster, what do I need to do? I need to support 2 clients. Okay, normally I have 2 clients. Okay, I'm a service provider company. Let's assume that I'm a service provider company. I'm providing storage services to them. That means they are just hosting their data, applications, everything in my storage, and they are paying money for that. Okay, let's assume in that way. For example, one client is ABC. Okay, another client is XYZ. Okay, these are the 2 clients which are utilizing my infrastructure to store their data. Now, What I'll do, let's assume that I have used a different vServer for both the clients. I have created a vServer called SVM1 for my client ABC, and I have created another SVM called SVM2 for my another client XYZ. So I'm creating volumes, queue trees, and presenting those things via this SVM for my ABC client servers. Okay, for their request, and I'm presenting storage via SVM2 for my XYZ client request. Okay, so far on storage level, I'm segregating everything, no problem. Like whatever I assigned through SVM1, okay. Yeah, sorry. I forgot to mention one more thing, very important. You need to remember. You need to know that before proceeding with the IP space. Okay. So again, normally I told you, right, IPv4 and IPv6, and we discussed about IP v4, right? IPv4, the classes of IP address and all. Again, in IPv4, okay, there are two types of IPs in IPv4. First one is private IP. Second one is public IP. Okay, private IP and public IP. Private IPs are free, and you can use them anywhere. Okay, and you can anyone can use anywhere. Okay, anyone can use them. Next thing is public IP. Public IPs they are chargeable. That means if you want to use a public IP, okay, you need to pay money for internet service provider. Okay, so these are owned by internet providers, internet service providers, ISP. That means Airtel, Reliance, Tata in India. When it comes to USA, like Verizon, these companies own that. In Australia, Three Mobile, these kind of telecom companies will own these public IPs. Okay, when you need a public IP, you cannot use it directly just like a private IP. What you need to do, you need to purchase them, then only you can use them. For example, your company is having a website. Okay, let's take an example of Facebook only. Okay, facebook.com. Okay, so in order to make this site accessible from internet, I need to purchase a public IP address. Without public IP address, this website cannot be accessible from internet. With a private IP, you can access within your organization. Okay, with a private IP. But if you want to make that website available in internet, you must use public IP. Without public IP, you'll be not able to use uh, uh, make that website available in internet. Like whatever the websites you are accessing in internet, right? All of them will be having public IPs in the backend. All the websites. Okay. So yeah. So whenever you want to host a website in internet, you must buy a public IP address. Public IP address will be linked with uh, yeah, that your website. So private IP you can use it anywhere. Like for example, just want to establish a small network in my home. Like for example, let's assume that I have two laptops or I have three laptops in my home. What I just want to do, I can connect all these laptops together with cables. I can assign IP address, private IP, 10 dot 10 dot 10 dot 11. Okay, 10 dot 10 dot 10 dot 12. Okay, 10 dot 10 dot 10 dot 13. Yeah, I can assign the range with the private IP. I can establish the communication between these laptops. Normally, I'm not sure how you'll copy the data when you buy a new laptop. Normally, people how they will copy, they'll copy it through pen drives and hard disk, right? From old laptop to new laptop. There is a way that you can copy without pen drives and laptops. Everyone is having routers and Wi-Fi's in their home these days, right? So what you can do, just uh, get a internet cable, normal LAN cable, connect your both of your laptops to the your Wi-Fi, and disconnect the Wi-Fi from internet for some time. Just configure IP address, private IPs to both of your laptops. Even you need to disconnect your laptop also from internet and assign private IPs. Okay, so that those two laptops will be able to communicate with each other, and you can copy the data through that Wi-Fi connection. Okay, you can do that. So these private IPs are for internal purpose. Normally, not only here, I don't know that if you have observed it or not. For example, if you went to internet cafe, they'll be having like 10 or 20 systems, right? Okay, right? So all of them connected to internet. You'll be able to access the internet via all the systems, right? That means, do they all of them will be having public IP? No, no, right? Normally, how they'll do, they'll create a small private network by using private IPs, and only one system will be connecting to public IP directly. That means to internet directly. Okay, internet. So with the help of that system only, remaining systems will can access the internet. Not all of them connected to internet. All of them are in a private network. Okay, and there is only one system or one laptop or desktop connected to internet. So with the help of that system only, remaining systems will be connected to internet. Okay, this is how they'll design it in internet caves as well. Okay, so private IPs, as I told you, you can use anywhere, but only public IPs you need to purchase them. Okay, so these are the ranges. Like there are few ranges in class A. Okay, entire 10 dot is a public IP. Sorry, private IP, not public, private IP. In class B, 172.16 to 172.31 is a private IP range. That means you can use these IPs also anywhere. And in class C, you have 192.168.0.0 to 192.168.255.255. This is the private IP. So these IPs you can use everywhere, anywhere, whenever you want. Everyone can use them, anywhere you can use them. But if you want to use a public IP, like whatever the IPs apart from these range, outside these range, they are public IPs. So if you want to use them, you need to purchase them. You cannot even if you assign an IP address outside this range, they'll not work. Okay, they'll not work. Got it? Any questions? In our lab also, I don't know that if you observed it or not, we are in this range 192.168.0 network we are on, right? Observe, see, 192.168.0. That means we are using private IP only. Not only here, in your organization also, mostly the whatever the servers, storages, everything will be using private IPs only internally. Even whatever the websites you will use for internal purpose, like for example, timesheet filling websites or internal communicator websites will be there, right? Announcement websites, all of them will be using only private IPs only, linked with private IPs only. Whatever the things needs communication with internet, those kind of websites and all, only they will be linked with the public IPs. Okay. Any questions? The private IP, you can use them anywhere. Anyone can use them. Now let's talk about IP space again. Sorry for that. Make it. Which board is better, whiteboard or blackboard for you? IP space. So again, let me draw the same diagram. Let's assume that I have a 4-node cluster. I'm taking the same scenario. Okay. So this is my cluster. And as I told you, I have two clients. ABC is one client and XYZ is one client. And they're just utilizing my storage services by hosting their data in my storage system. And I have created two separate SVMs for both of them. Okay. SVM1, SVM. Normally, so whatever I assigned through SVM1, it is only for my ABC client. Whatever I assigned through SVM2, that is for my client XYZ. Okay, on storage level, I'm segregating them via SVM. Then what about the network level? My office network is same, right? How can I segregate them at network level? And how can I segregate them on storage level also, and interfaces and all there, right? How can I segregate them at storage network level? For example, as I told you, see, I have interfaces also here, right? I'll be using the same network. And as I told you, everyone in organization, they'll be using private IPs only. Let's assume that there is a server in my ABC client, and I have a server in XYZ client. Both of them are assigned with the same private IP address. For example, 192.168.0.133. And these guys are also using same IP address for their server, because this is a private IP address everyone can use within their organization. But I'm a third party storage vendor who are providing the storage services to them. I have a communication with them and I have a communication with them as well. So now my ABC client asked for a 20 GB of storage. Okay. So what I have done, I have created a 20 GB volume. I have created a 20 GB volume here. Okay. And I linked with SVM1. I presented it. Okay. On SVM level, on storage level, my SVM will make sure that it should be assigned to the client that belongs to ABC only. But when it enters into the network level, it might get confused, right? Because I have a same IP address. I have a server with the same IP address with ABC client, and I have a server with the same IP address with XYZ client as well. So when it enters into the network level, my storage will get confused, right? So this is what we'll call it as a IP overlapping. That means I'm supporting two clients and both the clients are using the same IP address in their private network. As I need to communicate with them, okay, as they are using the same IP address, my network will face some complexities, right? So in order to avoid these kind of things, what we can do, I'll create a two separate IP spaces for them. IP space 1 for my client ABC and IP space 2 for my client XYZ. So IP space is a feature which can divide divide resources, which can split the resources. Okay, which can split the resources. That means my SVM1 belongs to IP space 1. Okay, my SVM2 belongs to IP space 2. Okay, and whatever the this particular interface, I'll assign it to IP space 1, and I have another interface where I have created list for this SVM. This belongs to IP space 2. Like that, by using IP space, I can split the resources in my cluster. Okay, I can divide the resources in my cluster. So whatever the resources I am using in IP space to, if I am assigning storage through them, then it will go to this particular server only. And whatever the resources I am using in IP space 1, if I am using the resources in IP space 1 to assign storage, then by default it will go to this particular server. So by using IP space, I can segregate the things, I can split the things, I can split the resources. Okay, that is the main purpose of IP space. Okay, I'll show you practically, you'll get more clarity. So by default, okay, by default there are two IP spaces. One is a default IP space and another one is a cluster IP space. Generally, cluster private network is there, right, which will establish the communication uh, between our nodes within the cluster. All of them will be in cluster IP space. Actually, we don't touch cluster IP space. Okay, we do not touch cluster IP space. Remaining everything, whatever the V servers, remaining whatever the lifts, everything will fall into default IP space. If you are not using IP space concept, then everything else will fall into default IP space. Let me show you that in our lab. Network IP space show. If you run this command, see, I'm able to see two IP spaces. One is a cluster IP space, another one is a default IP space. So whatever I create, everything they'll fall into default IP space. And whatever these, see, this cluster private network and all fall into cluster IP space. So we don't need to worry about the cluster IP space. Only thing is we need to worry about the default IP space, or if you are creating any IP spaces. And if you see here, my cluster and my V server, data V server, everything is under IP space, default IP space now. Okay, now let me show you how to create another IP space. Network IP space create, IP space name IP space 1. That's it. Now network IP space show. See, I have created another IP space called IP space 1. Now, whenever I'm creating a V server, I need to specify the IP space as well. If I don't specify any IP space, again, it will go to default IP space only. Let me create another V server. Okay, V server, create V server name, SVM2, subtype default, SVM2 underscore root volume security style, NTFS, and aggregate. We need to mention all these things, right? After that, there is an option called IP space, where you can mention which IP space this particular cluster belongs to. So this particular data V server belongs to. That's it. So that, see, I have segregated my cluster resources with the help of IP spaces. See, now my SVM1 belongs to default IP space and my SVM2 belongs to IP space 1. Okay, like that. If you see here now, see, SVM2 belongs to IP space 1. So IP space will help us to segregate the resources within the cluster. Okay. Any questions? No. Now we have another concept called broadcast domain. Okay, broadcast domain. CIFS, and I want to configure ISCSI. Okay. Let's assume that this is a NAS, not CIFS. Let's assume that this is a NAS, and let's assume that this is a ISCSI network, and I'm using a different subnet 192.168.0.x network for my NAS, and I'm using a different network for okay, for my ISCSI. Okay, let's assume that a different network. So normally I want to use all node one, all port ones on all nodes to for NAS. Okay, and I just want to use port twos on all nodes to for ISCSI. Okay, I'm using second port to configure ISCSI lifts. Okay, let's assume that simply, and I'm using um, port ones to configure NAS. Okay, ISCSI is a SAN protocol, right? Let's ignore that. And normally, just think that I'm using ISCSI for this. Okay, so normally what happens is, so here I have created a leaf. Okay, this is a leaf with let's assume that 192.168.0.133. Let's assume that. Now, for example, there is some problem with my leaf. Okay, there is some problem with my network port. Let's assume that network port is E0A. This is a E0B. Okay, again, this is a E0A on my node to E0B. E0A, E0B, E0A, E0B, like that. Okay, so let's assume that my node 1 E0A went down due to some problem. So the advantage with Leaf is it can move to other ports and still the same IP address, whatever the 192.168.0.33, right? That will still work. Okay, that is the advantage, another advantage of Leaf by using Leaf. For example, my E0A on node 1 went down. So what will happen? This Leaf can move to other port in the same node or other port as well. It can go to anywhere. Okay, it will move to other port in the same nodes also. It can move to other ports in the other node also, different node as well. Okay, and from there till the IP will be pingable to you. Okay, the IP will be pingable to you, and the data will be transferred via that particular IP address and the port. Okay, this is the advantage of Leaf. But the thing here is my E0A ports are connected to a different network, and my E0Bs are connected to a different network. You can configure multiple IPs, multiple lifts on top of a single physical port. There is no problem in that. But the IP address should belongs to same network. That means I have configured a IP address called 192.168.0.133 here, which belongs to this network only. That's fine. I can configure another lift with the same network IP range 192.168.0.134. Yeah, I can do that. But can I configure a lift, another lift with a different network IP? No, that cannot be done because that belongs to a different network. You cannot configure multiple lifts with different IPs, different IP networks in the same interface. That is not possible. We can configure multiple IPs, multiple lifts, but those IPs should belongs to a same network. Okay, because a single interface cannot be connected to multiple networks, right? This is a different network, this is a different network. Here my EasyReact is connected to this particular network. That means you can configure IPs within this network only, then only it will work. If you configure an IP of a different network on top of this interface, it will not work because my interface is not connected to that particular network. Okay, did you got it what I'm saying? So for example, my EasyRoya went down. So I have two lifts configured on top of EasyRoya, right? 134 IP and 133 IP. These two lifts should move to a different interface or a different node, different interface. For example, they move to this particular interface only. But what will happen? These lifts, the IP will not work, right? Because this particular interface connected to a different network, which is a 10.x.x some network. But the lifts are configured with 192.168 network, so that my 133 IP and 134 IP will become not reachable. That means my clients who are using these IPs to access storage, they'll be not able to access storage anymore because the lift moved to wrong interface, which is connected to a different network. So in order to avoid these kind of issues during the port failures or lift movements, lift failovers, what we'll do, we'll use a concept called broadcast domain. So broadcast domain means nothing but by using this broadcast domain concept, we can group the ports. For example, I have created a broadcast domain called NAS PD, NAS broadcast domain. And what I'll do, I'll put my node 1 E0A, node 2 E0A, node 3 E0A, node 4 E0A, like that, all node ports into this particular broadcast domain. That means all E0As on all nodes. I just created a broadcast domain and I configured, I added all of them to this particular broadcast domain. And I have created another broadcast domain, which is SKC. So iSCSI PD, iSCSI broadcast domain. And what I'll do, I'll add all the iSCSI interfaces here. Node 1 0B. Okay. Node 2 E0B. Node 3 E0B. Node 4 E0B. Like that. Okay. So now when if something wrong happened with my node 1 E0A interface, whatever the lifts I have configured on top of that particular interface can be moved to other ports in the same broadcast domain. That means what are the other ports I have in this broadcast domain? Node 2 E0A or node 3 E0A or node 4 E0A. So these lifts might move to either node 2 E0A or node 3 E0A or node 4 E0A. That's it. They'll not move to E0B because E0B is part of a different broadcast domain. It is not part of the same broadcast domain. Okay, like that. So by using broadcast domain, we can eliminate that accidental movement to a different network ports. Okay, did you got it what I'm saying, or do you want me to repeat it, or do you have any questions? So by using broadcast domain, we can we can configure where the lift has to move in case of a particular port failure, or in case of my entire node went down, then where it has to move. So we can configure that. Automatic lift movement can be configured or can be decided with the help of broadcast domain. Okay, any questions? Guys, if you don't understand, just respond to me. Then only I can understand, right? You are not able to understand. Then only I can repeat it, right? Just respond.
It is clear, Annaya.
Okay, thank you. Okay, so what is the command to check the broadcast domains? Network, port, broadcast domain, show. Okay, this is the command to check the broadcast domain. Again, just like IP spaces, we'll be having two broadcast domains by default. One is a cluster broadcast domain and another one is a default broadcast domain. And cluster broadcast domain belongs to cluster IP space and default broadcast domain belongs to default IP space. And I have one more IP space, right, which I have created IP space one, but I don't have any broadcast domain belongs to that particular IP space. So as all the port belongs to same broadcast domain, any lift I've configured on all the any port can be configured within this. Okay, for example, what I'm going to do, going to create one broadcast domain. Okay, broadcast domain, create broadcast domain name, for example, CIFS. MTU means maximum transition unit. Okay, generally we'll use only two MTUs. Either it will be 1500 or it will be 9000, something like that. Only those two MTUs we'll use. Again, MTU is will get a recommendation from network team. Okay, which MTU to use, but mostly it will be like 1500 or 9000. So you'll get the MTU value also from network team whenever you are configuring this. So you need to check with them which MTU you need to use. Mostly 9000 will be used only if you have a VMware environment. 9000 MTU, we'll call it as a jumbo frame. Okay, we'll call it as a jumbo frame. Nothing, guys. Normally in network, the data will be traveling as a in the form of packets, right? For example, if I copy a 1 GB file, okay, what it will do, it will be converted into a small packets, like 1 MB packet. It will be converted into small packets. I'm just taking 1 MB as an example. Okay, it is not exactly. Okay, packets. Okay, it will be traveled like that. So this MTU means nothing but the packet size. You can say that, just to understand yourself, you can say that. Okay, so generally in our lab environment it is a 1500. You can use 9000 also, but that is what I'm saying. It is based on how your network is configured. If your network is configured with a 9000 MTU, you need to configure 9000. If your network is configured according to 1500 MTU, then you need to configure 1500 on your end as well. This is, you need to get this detail from network team whenever you are configuring your broadcast domain. Next thing is ports. Let's ignore about the ports. Let's create a normal broadcast domain for now. Network port, broadcast domain, create broadcast domain name and MTU. That's it. And here it is asking for the IP space as well, right? Because as I have not mentioned any IP space, by default it will go to default IP space. Now what I'm going to do, I just want to separate my ports, right? I want to use E0D for my CIFS. So what I'm going to do, network port broadcast domain, remove ports. From which broadcast domain I'm removing the ports? From default broadcast domain. What all ports I'm removing? E0D, node 1 E0D and node 2 E0D. Okay. And if you network port broadcast domain show, if you run this command now, see I'm not able to see E0D port on top is part of my default broadcast domain. Now if you run network port show command, normally here also it will they'll display you which they are part of which broadcast domain and which IP space. See, my E0D is not part of any broadcast domain on both the nodes. So now what I'm going to do, network port, broadcast domain, add ports. Which broadcast domain do you want to add? I want to add them under CIFS broadcast domain. Okay. Same way, I just want to add both of them. If you see network port broadcast domain show, see now I have two broadcast domains under default IP space. One is a default, another one is CIFS. So now if I have configured a leaf on top of my node 1 E0D, it can be moved to E0D on node 2 only. It cannot be moved to other ports like E0C, E0E, E0F, E0G, or like that, because as I told you, a leaf can be moved to the ports within the same broadcast domain. Okay, it cannot be moved to the ports in the different broadcast domain. That is the purpose, right? Why we are creating a broadcast domain, so that it will not accidentally fail over to a wrong port which is connected to a different network, right? Like that, you can create multiple broadcast domains according to your requirement. Okay, any questions? For example, uh, two ports are not enough for you. Like if you want to configure another port for CIFS, just what you need to do before creating leaf on top of that, you need to remove the E0E from a default broadcast domain and add it to the CIFS broadcast domain, then only configure the leaf. Guys, one more thing, these all broadcast domains, IP spaces, all these things you need to do, you need to configure them, okay, before configuring the vServers and before configuring the leafs. Okay, once you configure the leaf on any port, you cannot change the broadcast domain of that particular port. Okay, so whatever the things related to network, these things will be done during the cluster setup only. Okay, these things will be configured during the cluster setup only. Okay. Okay, let me add few more ports. Okay, network port, broadcast domain, remove port, broadcast domain name. I want to remove the port from default broadcast domain. Which port you want to remove? Node 1 E0E, node 2 E0E. Let me add them to CIFS broadcast domain. Broadcast domain, add port. I have already created CIFS broadcast domain, right? Now I'm adding the port to that. CIFS broadcast domain, node 1 E0E, comma, node 2 E0E. That's it. Now see, network port broadcast domain show. See, now I have 4 ports in this broadcast domain. Now let me configure the leaf quickly. Okay, I'm configuring it on E0D. Address 192.168.0.121. Net mask 255.255.255.0. Status admin up. Okay. Now I have created a network interface, right? Now it is on node 1 E0D. Now let me show you how to move it manually. Network interface, migrate, server name, which leaf you want to move. Leaf 1, where you want to move. I want to move it to node 2. Which interface you want to move. I want to move it to E0E. Okay. Now see network interface show. See, now it is on node to E0E, but it is showing is on home. No, what is the home port actually? Home, the lift is actually created on node 1 E0D, right? But right now it is on node 2 E0E. That is the reason it is showing false. You can ignore that. Okay, see, I'm able to move the lift from one port to another port, and not I have moved it to a different node as well. Now let me try to move it to E0G. Will it move? No, it will throw an error because E0G is on different broadcast domain than lift home port. See, it will show you the same error. See, destination port node to E0G is in a different broadcast domain than the home port of the lift. Okay, that is the reason it's showing, it is throwing an error. That means you can move a lift from one node to another node, one port to another port, but the source and the destination ports must be in the same broadcast domain. Okay, now did you understand the purpose, Zubair? Amar, guys, please respond. Like if you respond properly, then I'll get an interest to explain you clearly. Or else I don't know, right? If you understand it or not.
Yeah, I understand, bro.
Okay, thank you. So like that. So based on how you want to configure, yeah, you need to create a broadcast domain and divide the ports into broadcast domain groups. Then only they'll not fail over to wrong port. Okay, which is connected to a different network, right? Yeah. Not only you can migrate them manually. If something, as I told you, if something wrong happened with that particular port, then automatically also lift will move to the other ports in the same broadcast domain. Okay, it is automated also. Okay, so that your IP will be reachable to the client. Now, so how to bring the lift back to home port? Now it is not on home port, right? It is on node 2 E0E, but the actual home port is node 1 E0D. Nothing, pretty simple. Network interface, revert server name, lift name. That's it. So that it will come back to home port. Now see, again it came back to home port. So yeah, this is the command to bring the lift back to home port. So you don't need to find it manually. Just use a revert command, automatically it will come back to home port. You don't need to move by specifying the home port and all. Okay, so that is the purpose of the broadcast domain. The main purpose is to make sure that the lift will be only moved to a different node or different port which is connected to same network, so that the IP will be still reachable after moving to a different node or a different port. Okay, that is the purpose of broadcast domain. So now let me show you the remaining things on broadcast domain. So now I have 4 ports on CIFS broadcast domain, and I have 6 ports on default broadcast domain. Now I want to configure a separate broadcast domain for NFS also, because I'm using a different IP address range for NFS. I don't want to use the same IP address as a CIFS. I just want to use a different network for NFS. So yeah, again, you can create a same broadcast domain. Or else, instead of creating a broadcast domain, what you can do, there is a command called split as well, which they have introduced recently. Okay, network port, broadcast domain. From which broadcast domain you want to split? Default broadcast domain. What is the new broadcast domain name? NFS. What are the ports you want to split? You need to specify them. E0G. Okay. See now, network port broadcast domain show. See, now automatically it created a new broadcast domain and it removed the ports from the default broadcast domain and it added them to the new broadcast domain called NFS. See, earlier in order to create a CIFS, we have to we did it in multiple steps, right? First I have created a broadcast domain called CIFS. After that I have removed the E0D E0E on both nodes from the existing default broadcast domain. After that I have added them to the CIFS broadcast domain. It contains 3 steps, but recently they have introduced this concept called split. So by using this split command, in a single command I can do all these 3 steps, right? I did all these 3 steps. It created a new broadcast domain, NFS, and it removed the ports automatically from the default broadcast domain and added them to the new broadcast domain, NFS, right? So by using split command, you can split the ports from the broadcast domain and add them to the new broadcast domain. Okay. For example, after that, I decided I don't want to use separate IPs for NFS and CIFS. I just want to use the same IP address network for both NFS and CIFS protocol. In that case, you don't need to maintain separate broadcast. You don't need to maintain separate broadcast domains for NFS and CIFS, right? Still, you can maintain them separately if you want. But as they are using the same network IPs, you don't need to, right? So what I'm going to do now, my plan is to combine NFS and CIFS broadcast domains as NAS by using this command. So what I'm going to do, network port broadcast domain, there is a command called merge. Okay. So which broadcast domain you want to merge? NFS broadcast domain to which broadcast domain? Into CIFS broadcast domain. Okay. That's it. So what it will do, it will merge both broadcast domains. See, I don't have NFS broadcast domain. Whatever the ports in NFS broadcast domain also, they are also merged into CIFS broadcast domain. Now, after that, I'll simply change the name. If you want, rename, not remove ports, sorry, rename. What, which broadcast domain you want to rename? CIFS into what is the new name? NAS. That's it. Yeah. Any questions on split and merge commands?
No.
Cool. Thank you. Now let me configure. As I told you, I can configure multiple lifts on a single interface. I'm configuring lift 2. Okay. On home node where I want to configure on node 1 only. On home port E0D only. Address 192.168.0.122 hyphen net mask 255.255.255.0 hyphen status admin up. And if you see now network interface show, see I have configured 2 lifts. Both I have configured on the node 1 E0D only. That is what I told you, right? You can configure multiple lifts on a single interface also. But only condition is those IP addresses on top of lift, whatever we configuring, that should belongs to same network. Then only those lifts will work. If you configure a different network IP, it will not work. That is what I told you, right? Yeah. Like that, you can create a number of lifts. Only thing you need to keep in mind, what is the port speed of that particular port where you're configuring this lift. For example, here on node 1 E0D, what is the speed of that port? If it is a 1 gig port, then if you configure multiple lifts, then it will create it might impact the performance. If it is a 10 GB port, then you can configure multiple lifts without any problem. Okay. Yeah. Someone unmuted. Any question?
No, but how we will get to know that port is particular speed port?
Is
Client
if you
will.
no. If you run network port show command, it will show you. Here it
Yeah,
is 1000. 1000 means it is a 1 GB port. If it is
yeah.
showing as a 10,000, it is a 10 GB port. Here, if
Okay,
it will show you as a 100, that means that is a 100 MB port.
okay, okay,
It is displaying the parameter as well. It is Mbps. Okay,
okay, okay. Fine, fine.
no problem. Next. So yeah, that is broadcast domain, network port broadcast domain. So yeah, like that, you can create a broadcast domain. You can split a broadcast domain. You can merge two broadcast domains into a single broadcast domain. Okay. Now, if you want to delete network port broadcast domain, but in order to delete a broadcast domain, you need to remove all the ports from the broadcast domain. But as we have merge and split, do we need to create and delete broadcast domains? Not required, right? Again, that contains multiple steps. But I'll show you how to delete it in a traditional way. But instead of delete, what you can do, merge NAS broadcast domain into default so that everything will be moved to default broadcast domain as a default setup, right? That is the recommendation I'll do normally. But normally, if you want to delete the broadcast domain in a traditional way, what you need to do, you need to remove the ports first. Okay, from where you want to remove from NAS, what are the ports you need to mention each and every port. But can we use star? Let's see. No, we need to. Yeah, all commands will not support star. E0E, E0F, G. Okay, same way. Let's do it for node 2 as well. Node 2 E0E, node 2 E0D, mm, E0F, E0G. Okay. Uh, okay, D is not part of that. D is part of a default only, I guess. Okay. D we cannot remove because there is a leaf already configured, right? In order to remove the D from the broadcast domain, what you need to do? You need to first delete the leaf. See, you cannot. It will not allow you to delete the D. So you need to delete the leaf first. So in order to delete the leaf, first you need to bring it down. Okay, network interface modify vserver name, leaf name, status admin down. Okay, first you need to bring the leaf down, then only it will allow you to delete. Network interface delete, vserver name, leaf name. And now You can remove E0D as well. Node 1 E0D, same way node 2 E0D. I don't have leaves, right? Do I have multiple leaves? Oh yeah, we have created multiple, right? So yeah, we need to bring lift 2 also down and delete lift 2 as well. Okay, now you can remove network port broadcast domain show. See, now I don't have any ports in this broadcast domain. So what I need to do, I need to delete it. Network port broadcast domain, delete NAS broadcast domain. Okay, now if you run show command, see it is not displaying. Now I need to again add all these ports to default broadcast domain. Network port broadcast domain, add ports, default broadcast domain. I think, can we do start? No, it is not allowing wildcard entries. E0D, E0E, E0F, E0G. Same thing with the node 2 as well. E0D, E0E, E0G, E0F. Okay, network port broadcast domain show. Okay, see everything back to normal. Everything is in default broadcast domain like that. Okay, any questions on broadcast domain? If you are good, then I'll show you IP space.
We are good, Anaya.
Okay, thank you. So I told you, right? As I told you, we can split the resources with IP space, right? So network port broadcast domain, I'm using a split command to create a new broadcast domain. Which broadcast domain I'm splitting? Default broadcast domain. Into which, what is the new broadcast domain name? Like for example, XYZ. What are the ports you want to remove? Split. I just want to remove D and E from both the nodes. Okay. IP space as well. I just want to move it under IP space 1. Okay. Yeah. So I think split will work within the IP space only. If you want to if you want to create a broadcast domain in different IP space, I think we need to create it. Network broadcast domain, sorry, network port broadcast domain, remove ports from default. What are all ports I want to remove? I have a list here, right? Let's use that. Okay. Now let's create a network port broadcast domain. Create XYZ MTU 1500 IP space, IP space 1. Now network port broadcast domain, add ports, not default actually. I want to add it in the IP space. So whenever you are adding them, first mention the IP space, IP space 1. So broadcast domain automatically it will show you. Okay, so what all ports you want to add under that broadcast domain which is in different IP space? You need to mention that. That's it. Now see network port broadcast domain show. See now this particular broadcast domain is under this IP space. That means now my SVM2 can use these ports. Okay, let me give you a clarity here. If you run vserver show SVM2, right? Okay, and SVM2 belongs to which IP space? We have created it already. And let me show you network IP space show SVM2 belongs to IP space 1. Okay, and SVM1 belongs to default IP space. So SVM1, okay, can utilize the ports available in default broadcast domain only. It cannot utilize the ports in XYZ broadcast domain. The same way SVM2 can utilize the ports in XYZ broadcast domain only. It cannot use the ports in default broadcast domain. So because I have splitted the resources by using IP spaces. Let me show you that. Let me give you a demo. Now I just want to create a leaf vault of SVM1 by using the port in XYZ. See what happened. Network interface, create vserver name SVM1 leaf1 service policy role home node 1 home port E0D. E0D belongs to actually XYZ. Okay. 192.168.0.121 net mask 255.255.255.0 and status admin up. See, it will throw an error. The specified port and on node 1 port E0D is not the same IP space as vserver SVM1. Okay. Now if I do the same for SVM2, it will allow because SVM2, my vserver and my broadcast domain belongs to same IP space, right? See now it created. So if you are working in a multi-tenant environment, multi-client environment, then only IP space will come into picture. Okay, but if you are supporting a single client, then IP space will not use IP space mostly. But if you are supporting multi-client environment like a single resources are sharing with multiple clients, then we must use IP space environment to split the resources. Yeah, did you got it now? Like by using IP spaces, we can split the resources. See, I have splitted the ports. I have splitted the vserver. I have separated the vserver and ports from into two different spaces. One space cannot utilize the resources in other space, other IP space. Okay. Any questions? This is one of the complex class actually. Yeah. Okay. Yeah. If you understand, then yeah, let's stop it for today. We'll finish the remaining networking concepts tomorrow. Like if group, VLAN and all, we'll do it tomorrow.
Okay.
Okay. Thank you. Let me know. Like, yeah, you can call me directly if you still understand, if you still don't understand, and if you don't want to mention it in front of everyone. Not a problem. Thank you. Have a nice day, guys.